Here we are at problem 3, capital B. We're looking at the graphical method for estimating a limit. Now for part 1, we see that we have the limit of f of x as x approaches 0 from, really when you see that negative sign, it means that you are approaching 0 from the left. So we are approaching 0 from the left. And as a result, you can see that as you approach that x value 0, then you end up with a y value, or limit, of 3.5. So our limit comes out to be 3.5. For part 2, we have the limit of f of x as x approaches 0 from the right. Anytime you see that plus sign, kind of like in that exponent area, that means that it's going, or it's coming at least, from the right. So as you approach 0 from the right side, we see that that limit comes out to be 5. Now the limit of f of x as x approaches 0, notice there's not any left or right, minus, plus, whatever. This one actually does not exist. And the reason it does not exist is because our left-sided limit does not match our right-sided limit. So again, the reason is because the 3.5 limit did not equal our 5 limit. All right. For part 4, it's asking the limit of f of x as x approaches 2. Well, again, for part 4, it's not really specifying left or right. So as you approach 2 from the left or the right, it actually has to satisfy both. So notice that it is in fact meeting up at the exact same point. This limit of appears to be 1/2. So for part 4, we end up with a limit of 1/2. For part 5, we have the limit of f of x as x approaches 4 strictly from the left. Well, if you approach 4 from the left side, you notice that it's going up and up and up and onwards towards positive infinity. So then that limit will go on to positive infinity. The limit actually does not exist, because you can't actually obtain infinity. But when you're stating infinity, you're kind of implying that it does not exist. This is actually a more certain answer, or final answer, because when you state that your limit is infinity, you're also kind of stating indirectly that it does not exist. This one actually should say, what is the limit for part 6? It should say the limit of f of x as x approaches 4 from the right. There should be a little plus sign there. Not really sure why it's not there, but it should have that plus sign. So if we look back to our graph, as you approach 4 from the right side, you can see that again, it still is going towards positive infinity. So for this limit, it comes out to be positive infinity. Again, since you can't quite reach infinity, that limit would not exist. Now for part 7, the limit of f of x as x approaches 4. Again, no minus or plus sign, so it actually has to satisfy both left and right. So are they going to the same spot? Well, again, as you approach 4 from the left side and as you approach 4 from the right side, they actually are going in the same general area. They're going both upwards. So because they're actually going in the same upward manner, going toward positive infinity, this will actually come out to be positive infinity. And again, that limit still does not exist because you can't quite reach infinity. Now the limit of f of x as x approaches infinity, so if we just look back at our graph, well, that's really hard to determine because we don't have stuff that's kind of outside of here, like what's going on past 4. Is the graph maybe leveling off at 1/2? We don't know. Or is it maybe going down and then, going to hover 0? It's really hard to tell. So for this one, there's really not enough information. So not enough info. Simply because you really can't determine what's going on beyond this point. We don't really know. So now looking then at part 9, what is the limit of f of x as x approaches negative infinity? Well, again, going back to our graph, as you go outwards, it's really kind of hard to tell, but I think that this one's probably a little bit more clear than the one that was going out towards positive infinity. So I'm going to go ahead and say, because it is kind of more plateauing there, I'm going to go ahead and say that that is 2.5. But for this limit, part 9, we're going to go ahead and say 2.5. And if you're ever a little worried and you're kind of like, well, how do you know what you want? You know, because here we're kind of, I don't want to say guessing. Here we're not exactly saying an answer. How are you going to know which one is the true limit? Like, how would I actually get the points on like a quiz or test? And to be honest, on like the quiz and test and AP exam, they're not going to try and trick you. Like, we're not going to try and throw you off like that. There will be a very, very clear limit that it might be approaching. Otherwise, if it's something more like this vague, we're not going to do that to you. All right, so just kind of keep that in mind for like the quizzes and exams. Now, part 10, the limit of f of x as x approaches negative 2. Now again, since it doesn't have a negative or a positive, it has to satisfy both. And if we look very carefully, as x approaches 2 from the left, we see that it's approaching that limit of 1/2. So we'll just say 2 from the left is equal to 1/2. 2 from the right, if we look very carefully at our graph, we notice that as you approach 2 from the right, it also is coming out to be 1/2. And since both limits end up at the same spot, 1/2, that would be our limit then for part 10. So it comes out to be 1/2. Now, again, just kind of reiterating some points here. If the limits do not end up meeting at the same spot, that limit would not exist. And again, that happens specifically when you're not really specified with a minus or plus. So again, that's why for part 3 it does not exist, because the two points didn't end up meeting up. Whereas in like part 10, when we weren't again specified with a right or left, you have to then assume both. And you have to see, and hopefully they end up meeting at the same spot. And you can see that in part 10, they ended up meeting at the same spot. And that gave us the limit of 1/2. So again, that was the graphical method for us actually estimating a limit. Now let's go ahead and quickly talk about what is the mathematical notation. How that actually looks is we have the limit as x approaches some constant number. So C just stands for some constant of some particular function is equal to some limit. Alright, so that's actually the mathematical notation that we'll be seeing quite a bit in this first chapter, and then, you know, on a little bit even in like the second chapter. So again, that is the graphical method for estimating a limit, problem 3, capital B, from the 1.2 set of notes.